Assalamualaikum warahmatullahi wabarakatuh. Today our group will present about the structure of scientific reasoning.
Our group consists of four members, which is me, Nur Fadila binti Nur Azam, Nur Ida Shahira binti Abdul Rashid, Nur Soleha binti Yahya, and the last one is Wan Nur Amira binti Wan Ismail. So today, our group will present and will discuss with you guys about the definition, concept and example, advantages, weaknesses, and also application.
Okay, now we will go to the definition of scientific reasoning. What is scientific reasoning? Scientific reasoning represents the cognitive skill necessary to understand and evaluate scientific information, which often involve understanding and evaluating theoretical, statistical, and causal hypotheses. Scientific reasoning, also known as hypothetical reasoning, which is hypothetical reasoning, is used by nearly all of us in our day-to-day experience. The automechanic constructs hypotheses to determine why a vibration occurs at certain speeds. Other than that, the teacher also hypothesizes about the best way to present a complicated subject in the classroom and many more. Scientific reasoning also includes the thinking and reasoning skills involved in inquiry, experimentation, evidence evaluation, inference, and argumentation. The scientific reasoning also known as the production of explanations and also the reasoning process you use to produce a hypothesis, draw an implication, and test the implication. Scientific reasoning use inductive reasoning and deductive reasoning to advance the scientific knowledge. As an example that we can see, suppose you try to open a window but find that it will not budge. Since it is impossible to see what is jamming it, you make a conjecture. Perhaps the window has been pinned shut from the outside. If that is the case, then running a knife along the edge of the window from the outside should be out. You do this and the window opens. In solving the start window problem, the informed conjecture, which is conjecture also known as an assumption that you made, is a hypothesis, and the reasoning process you use to produce it, draw an implication, and test the implication, which is at the same time running a knife along the edge of the window from the outside, can fill it up, and when you do this and the window opens, is called hypothetical or scientific reasoning. Okay, now we go to the scientific method. What is scientific method? Scientific method, there are steps in scientific method, which is first observation, question, hypothesis, experiment, conclusion, and then result. There was 6 steps in the scientific method. The scientific method uses a series of steps to establish facts or create knowledge. The overall process is well established, but the specifics of each steps may change depending on what is being examined and who is performing it. The scientific method can only answer questions that can be proven or disproven through testing. First step in the scientific method is observation. The first step is to observe something that you would like to learn about or ask question that you would like answer. This can be specific or general. Then second step is question. We just make question that you would like answer, and then create a hypothesis. Create a hypothesis is an explanation for the observation or question. If proven later, it can become a fact. Okay. Then we go to experiment. Experiment, also known as create a prediction, and we perform a test. Create a testable prediction based on the hypothesis. The test should establish a noticeable change that can be measured or observed using empirical analysis. It is also important to control for other variables during the test. Then after we make an experiment and conclude the prediction, we can go into the conclusion. Conclusion and result. Okay, analyze the result and draw a conclusion. Use the matrix established for the test. See if the result match the prediction. Okay, so I think that's all from me. We continue to the next presenter.
Let's move to the concept of scientific reasoning. So, what is the concept of scientific reasoning? To make it easier, we can remember the acronym word CHER, which stands for claim, evidence, and reasoning. So, claim. What do you conclude or answer from your observation and hypothesis? Claim is an arguable statement and can be proven by evidence. In other words, the claim is an answer to a question that is being asked. Next, evidence. What data prove the claim? Data or fact must come from reliable sources. In a simple word, evidence is data or proof to support the claim. Lastly, reasoning. How does your evidence support the claim? Reasoning is a logical connection between the claim and the evidence. Reasoning is also to defend the evidence. Why is this evidence a good evidence to support the claim? To conclude, what is CHER, or the concept of scientific reasoning? CHER is a way to make or come up with an explanation or scientific argument. This is what we call as scientific argument or scientific reasoning. For a better understanding, let us take a look at the example. Imagine that we get a scientific question. Does a person's height change throughout the day? From this question, we tend to claim on our own that a person's height decreases throughout the day as gravity pulls down on their body. From the claim, we need to come up with evidence in order to support the claim. So, what is the evidence? Maybe we can say that the height of the students decreased by an average of 1.7 cm throughout the day. If you can see here, the evidence or data that prove the claim is based on the observation we made by measuring students' height with their time spent per day. We observe that the height of each different students decreased by an average of 1.7 cm throughout the day. After making a claim and evidence, we must come up with the reasoning, which can be the explanation of why and how the evidence supports the claim. The first reasoning is we saw an average 1.7 cm decrease in height across 15 hours per day. Second, we took the same measurements at the same time for each person. And lastly, students measured spent roughly the same amount of time sitting and standing. So that is how the concept of scientific reasoning is being applied from the scientific question we get.
Next, I will proceed to the advantages of scientific reasoning. The first advantage is it is clear to predict behavior, which enables theories and hypotheses to be created, tested, and falsified. Pavlov predicted that behavior can be conditioned in response to a specific stimulus. He tested this using a control observation where his dogs associated a bell ringing with being fed. He therefore conditioned the response of salivating when the bell was rang. He then created the theory of classical conditioning. This is an advantage of the scientific method, as it shows clearly how a prediction was tested, allowing a theory to be created. The second advantage is a major educational approach has focused on the interaction between different aspects and scientific thinking in a collaborative setting rather than analyzing the product of person thinking alone. Okay, firstly, we need to know what is collaborative learning. Collaborative learning is the educational approach of using group to enhance learning through working together. Group of 2 or more learners work together to solve a problem, complete tasks, or learn a new concepts. This approach actively engage learners to process and synthesize information and concepts rather than using rote memorization of facts and figures. Learners work with each other on projects where they must collaborate as a group to understand the concept being presented to them. Through defending a position, reframing ideas, listening to other viewpoints, and articulating their points, learner will gain more complete understanding as a group than they could as individuals. The last advantages is the use of specialized equipment, which allows quantitative data to be gathered and analyzed, which leads to greater level of objectivity. Example for this advantage is visual cliff experiments by Gibson and Walk that investigate the ability of newborn animals and human infants to detect death. Gibson and Walk tested whether youngsters would crawl over an apparent cliff if the neonates did. It could be assumed that the ability to see death was not inborn. So what we can relate with scientific reasoning is the procedure was a rigorously controlled laboratory test, so offer a reliable but also safe measure of depth perception, as it was possible to eliminate or counter the influences of other senses such as touch from the rat speakers. They ensure it was a valid test of visual perception. The consistency of the result over a range of species, including humans, adds credibility to the findings. However, the sample of human infants was quite small and the age range rather large, somewhere likely to have been crawling for something before they were tested. Although the mothers were present and gave informed consent, there was still a potential ethical issue. Simply looking at the drop or being encouraged to cross it by their mothers may have distressed the baby because they didn't know the glass was there to save them. So the investigation of the nature issue in perception didn't end with Gibson and Walk's research. This only explored the plasticity of infant perception. So the question of whether adult perception could adapt was not considered.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Fadila binti Nur Azam. Now I will continue the presentation with weaknesses of scientific reasoning. So we move to the first point, which is many of the crucial processes occur in the past and are difficult to test in the present. The scientific method is the process of objectively establishing fact through testing and experimentation. So the basic process that we learned just now from Ida's presentations involve making an observation, forming a hypothesis, making a prediction, conducting an experiment, and finally, analyzing the result. So for an example, the Greek philosopher Aristotle is a famous scientist that study and make experiment about gravity. Besides the discovery of proton, neutron, and electron that we learned in the Form 4 in the subject of chemistry, these electrons were discovered by scientists before, which were James Chadwick and J.J. Thomson in their studies and experiment. So the weakness is many of the crucial process occur in the past and are difficult to test in the present because both of these process or experiment are very important and they happen in the past and are difficult to test in the present because of several factors such as environmental and so on. We move to the second point, which is human error in recording observation or inaccurate use of measuring instrument. Okay, so for this point, it may be because of the human itself. When they conduct the experiment, they will not inaccurate of measuring instruments. So let's say that they have a data, and then people that are conduct experiment, they are lack of information, so the data will not tally with their experiment. And then the third reason is limited to the present. So what is now may not have been true in the past or in the future. So in this point, it explains about what is true now may not true in the future. So when we do the experiment now, it may be change the data or change the result in the future, and it may be not same with before because the data and the experiment will change depends on the surrounding and situation. And the last one is personal bias or cultural belief about the topic. So the weakness of scientific reasoning is when the human who conduct the survey, it has personal bias or cultural belief. So the people believe or have bias on his own experiment. So when the data is not tally with her experiment, and then when he has bias on his experiment, so they will do something to the data to make it more tally with her experiment. So this is the weakness of the scientific reasoning. Next, the application of scientific thinking in Islam. So, the critical thinking is highly demanded in Islam because it is a vision and a mission of Islamic religions. According to the Islamic epistemology, reason is considered as the second source after the revelation. And the ability of Muslim scientists in conducting a tadabbur and tafakkur has enabled Islamic scientific tradition to increase gloriously. And then the theory of the Islamic knowledge development process has three, which is Bayani approach, Burhani approach, and also Irfani approach. So for the Bayani approach, that means that Bayani approach is explanation and more inclined to text, and brain is considered secondary. So for the Burhani approach, it based on rational strength through logical theory, and the Irfani approach, similar to the Ma'rifat, the knowledge is obtained directly from experience and commonly applied, and this Irfani approach is commonly applied by Muslim Sufis. So we move to the last part, which is characteristic of scientific research. The first one is systematically. Systematically is when we do research with systematic, and when we do it with systematic, inshallah we will get the strong data or strong evidence because we do it with systematic process. And then logically also same with systematic, we use logic thinking to get the data or evidence or result. And then characteristic of scientific research is empirical, reductive, replication, and also tawakal. So we need to tawakal in our research. When we get something result, we need to praise to Allah, and when we don't get the result, we also need to tawakal to Allah. Okay, that's all from our group. Thank you for your listening and your time.